Hello students, welcome to ACE Online. So we all know we have started score booster series where we solve NAT and MSQ questions every day in the YouTube live. So yesterday we had the session on engineering mathematics. Today we have one more session on engineering mathematics. This is for computer science and data science students. So we try to solve the questions related to their syllabus. So like you have seen the schedule. So this is the computer science schedule, the data science schedule, electronics and communication, electrical engineering schedule, mechanical engineering schedule, civil engineering schedule, and then yesterday we have solved certain problems, and then students were asking about the notes. So if you want the notes, like whatever the live we teach, if you want the notes of that, you can scan this QR code. So this will direct you to a drive. From there you can actually download the notes. So shall we start the problem solving? So see, is this QR code working or not? And also please message me, is the audio, video, is everything, is the streaming going well? So once you message, I'll start the problems. Harshit says yes. Harshit, you can also scan this QR code. You will be directed to a drive. From there you can download it. You can also verify it. I have checked it. The drive, when I scan this, it directs me to a drive where from there I can download the PDF. Okay, so let's start with the first question for today's session. It says consider two functions. One is f is from r to r, g is from r to 1 to infinity. Both functions are differentiable at a point C. Which one of the following functions is are always differentiable at C? The symbol, the dot, denotes the product, and the symbol circle denotes the composition of the functions. And they gave the functions like f plus or minus g, f into g, f by g, and f circle g plus g circle f. So you all know we are interested to solve NAT and MSQ questions in this series. All the subjects will be covered, so every day you will have live sessions. Now you have to pick which are those options in which the function is differentiable at C. They gave us the information that f and g are both differentiable at C. So how do you handle? Now this is certain options are straightforward, like if you have two functions which are differentiable, then if you add them or you subtract them or you multiply them or you take the ratio, the new function that is created is also differentiable. So the new function that is created is also differentiable. So option A talks about addition. He's adding two functions or he's subtracting two functions. It is definitely differentiable. Here it's a product, here is the ratio, and I just want to check, can this denominator be 0? Because if the denominator becomes 0, the ratio becomes meaningless. I just want to know, can denominator become 0? There is no way. Why? Because g is a function from r to 1 to infinity. So whatever input values you give, g returns values from 1 to infinity. Hence the denominator cannot be 0. So it's a very standard thing. If there are two functions which are differentiable, you add, subtract, multiply, take the ratio, the new function is also differentiable. So I have no doubt in ABC because they are very standard. We all like regularly teach this in the classroom. The most interesting thing is option D. So I have already declared ABC as the right answer. I'm just left over with option D. So how do you solve for option D? So let's assume that h of x be f circle g, h of x be f circle g of x plus g circle f of x. So you can simplify this. H of x will be like f of g of x plus this is like g of f of x. Now I want to know whether this is differentiable or not. So I'll take the derivative on both sides. So h dash will be, it is f dash of g of x into the derivative of the inside quantity, that is g dash of x, plus it is g dash of f of x into the derivative of the inside quantity. So I want to know whether this is differentiable or not at c. So I want to find h dash of c. So which will be f dash of g of c into g dash of c plus it is g dash of f of c into f dash of c. So this is where we are. Now I want to know whether this is differentiable or not. I have no doubt in this term g dash of c and f dash of c. G dash of c and f dash of c exist. There is no doubt in that. But let's closely observe this. What is this? F dash of g of c. This is g dash of f of c. If you look at the problem statement, it is given that f and g are differentiable at point c. But if you look at this, where do we need the derivative? We need the derivative of f at g of c. We don't know whether the function is differentiable or not at x equal to g of c. So I'll write that point. Check this. So we have almost got our answer. So look at this note point, students. F of x may or may not be differentiable at x equal to g of c, because we need the derivative at x equal to g of c, right? We only know the function is differentiable at c. We don't know whether it is differentiable or not at g of c. So it is like may or may not be. Now same thing you can write for g of x also. See here you have g dash of f of c. So what point you want to write? G of x may or may not be differentiable at which point? At which point? At x equal to f of c. At x equal to f of c. We don't have this information. That's why I write may or may not be. So A, B, C are true. D need not be true. So the answer for this question is A, B, C. So a very good question which is related to MSQ. I hope you people have got this idea now. So let's proceed to the next question. And if you have any doubts, you can also post it. I'll be reading your comments. So let's see what is this question about. Consider the given function f of x, which is ax plus b for x less than 1, and it is x cube plus x square plus 1 for x greater than or equal to 1. If the function is differentiable everywhere, the value of b must be. So what they gave? That the function is differentiable everywhere, then the value of b. Okay. So the moment you say the function is differentiable, it means the function is also continuous. Yes or no? If a function is differentiable, it is also continuous. So what I'll do is I'll start like this. I'll see the left limit and the right limit at 1. So what is f of 1 minus? It has to be equal to f of 1 plus. So utilize this. So the left limit here you have to put in the place of x, put 1. So this will be like a plus b equal to, for 1 plus use this, it will be 1 cube, which is 1, 1 square 1, 1. So we get a plus b value as 3. So what next? With this you got one condition. If you use the derivative condition, then you get one more condition. With that you can solve for a and b. So write the derivative of f of x. What's the derivative of ax plus b? it is a. So this is for x less than 1. What is derivative of this function? It is 3x square plus 2x. This is for x greater than or equal to 1. Now since he says the function is differentiable, f dash of 1 minus has to be equal to f dash of 1 plus. So what's the left slope? The left slope is a. What's the right slope? To get the right slope, here you need to put x value as 1. It is 3 plus 2. So from this, the value of a is 5. Now once you know the value of a, you can get the value of b. So use that equation. 5 plus b is 3. The value of b is minus 2. So this answer, you have to fill it in this blank. So the answer for this question is minus 2. I hope you are all getting this. So one of the students says, can you do a 6-hour Maha Marathon of complete mathematics before gate? That will be useful. Actually, we do a revision session. So revision session is like a marathon here. So I'll give you those details of that revision session. So who is that? It is Soma something. I'm unable to pronounce the name. Okay, so whatever doubts you have, you keep asking. We will try to help you. So I'll give you the details about the revision session, which is not just one subject. All the subjects we do the revision like that. It's like a marathon only. So let's look at this question. A 3 cross 3 matrix A is decomposed into LU, where L is a unit lower triangular matrix and U is upper triangular matrix. It is known that L is this, U has these kind of entries. If the system AX equal to B, where B is 1 1 1, is solved using this LU decomposition, the value of the second component of the solution vector x, that is x2, is. So what he's saying, he gave you LU factors and he's talking about a system called AX equal to B. So when you try to solve for x, he wants the second component of the solution vector, that is x2. Can you solve it? So this is a very interesting question for computer science and data science students. You have LU decomposition in your syllabus. So how do you deal with the LU decomposition? So now what we usually do is we first write like this. So we have AX equal to B. Now A is factored as LU, so it is LU x equal to B. And then we assume that UX B, this UX B Y. Then in the place of UX, you can now substitute Y. So this will be like LY equal to B. So those who don't know how to deal with LU decomposition, look at this. You need to first solve this system, Ly equal to B. From that, get Y. Once you get that Y, you need to use the Y here and then solve this Ux equal to Y, and you have to solve for X. So this way you will get the solution X. So this is how the LU decomposition is done. So what's the first step? You have to solve the system which is Ly equal to B. So let's solve the system Ly equal to B. Is L given to us? Yes. So what is L? It is 1 0 0 2 1 0 0 3 1. Okay. Into Y. Y is unknown. So let's assume Y1, Y2, Y3. So Ly equal to what? B. Is B given? Yes. So which is 1 1 1. The nice way to solve this is called forward substitution. You start multiplying this with this, you will get y1 followed by y2 followed by y3. Forward like substitution. So when I take this row, multiply with this, I get the value of y1 as 1. When I take this row, multiply with this, let's see what do I get. It is 2y1 plus y2 equal to what? 1. But already have got the value of y1. So this is 2 plus y1 equal to 1. The value of y1 is, sorry, 2 plus, 2 plus y2 actually, 2 plus y2 is 1. So from this I get the value of y2 as minus 1. With y1, y2 you can get y3. How do you get it? Take this row, multiply with this. This will be like 3 y2 plus y3 equal to 1. So just now you got y2 value. So this is minus 3 plus y3 equal to 1. So what's the value of y3? It is minus 4. So this way we have solved. We got y, which is 1 minus 1 minus 4. With the help of y, now you try to solve ux equal to y, the system ux equal to y. We'll go to the next page. Now the focus is about solving ux equal to y. What is u given? 1, 1, 2, 0, minus 1, 3, 0, 0, 2, multiplied with this x which is unknown. Let's write as x1, x2, x3, where the focus or the final answer they want is x2 value, and this has to be equated to what? Y. Y is 1 minus 1 minus 4, 1 minus 1 minus 4. While solving ux equal to y, we use the backward substitution. That is, we first multiply this with this. So let's see what do we get. Multiply this with this. So this gives 2x3 equal to minus 4. The value of x3 is minus 2. Now take this row, multiply with this. So what do you get? Is it minus x2 plus 3x3 equal to what? Minus 1. So just now you got x3 value, substitute that. So it is minus x2 and then it is minus 6 equal to minus 1. So please check it, is the calculations correct? So this cancels. X3 is minus 2. So when I substitute, this is minus x2 plus 3x3. So this is minus 6 going to the other side. So from this, minus x2 is 5 and the value of x2 is minus 5. So see whether you people have understood this or not. Did you get this answer or not? So Ankit says, I have not completed AIML. Can I skip these 2 subjects? I don't suggest to skip any of the subjects. So you are supposed to cover as many subjects as possible. So another student says, sir, electrical same syllabus? No, electrical. Vishnu says y3 should be 4. Can you properly write what is the issue, Vishnu? Vishnu says y3 must be plus 4, it seems. Is it? Yes, y3 should be plus 4, Vishnu, you are right. So there is a mistake from my side. This is plus 4. If this is plus 4, then all these calculations will change. Y3 is plus 4, so this calculations will change. This is plus 4, this is plus 4, then this is plus 2. If this is plus 2, then this is plus 6, and then this will be minus 7. Actually, I was thinking like somewhere I have done a mistake. That's why I asked you people, can you check it? So somewhere I felt I have done a mistake, simplification mistake. So this will be minus 7. From this, the value of x2 is 7. Is this okay now? Ankit Singh, you should not miss any subject. So I request you to cover, put some efforts. You have, this is December 21st. Are you from computer science branch, Ankit? You are from which branch, Ankit? And Vishnu Sai, thanks for that correction. Let's proceed. I'm reading all your comments. Ankit says, sir, he's from CSE. So, are you preparing for CSE? Did your preparation complete for CSE, Ankit? There are many common subjects in computer science and data science paper. So, the weightage of AI ML, AI and ML is nearly 20 to 22 marks. So, if you are skipping, that means you are skipping these many marks. And then engineering mathematics also has a vast syllabus. So, to whatever extent you can prepare, you prepare. So don't, if you are writing only DA paper and you want to skip this, then it's a blunder. If you are writing computer science and data science and a computer science paper is your primary paper, then it's okay. Okay, let's continue. This is really a fantastic problem. One has to put a lot of efforts to solve this. Not that easy. Which of the following statements are true? So it's a multiple select question where R denotes the set of real numbers. What is option A? It says there exists a matrix M belonging to R power 3 cross 3. So basically when he says this, it means M is a 3 cross 3 matrix. P is a 3 cross 1 vector. Q is a 3 cross 1 vector such that Mx equal to P has a unique solution and Mx equal to Q has infinite solutions. So what he wants to tell you is there exists, he says, according to him, there can be a 3 cross 3 matrix M, a 3 cross 1 vector P, a 3 cross 1 vector Q such that Mx equal to P has a unique solution and the same M into X equal to Q has infinite number of solutions. So is it possible? Let us see. And then you have got various other options as well to analyze. So this is actually equivalent to 4 different questions, you know. Now when I read this question, I'll write like this: M is a 3 cross 3 matrix, P is a 3 cross 1 vector, Q is a 3 cross 1 vector, and then you multiply M with X to get P. So you should also know what is X. This is a 3 cross 3 matrix multiplied with some vector, and the answer is a 3 cross 1 vector. That means X should also be 3 cross 1, because when a 3 cross 3 multiplied with 3 cross 1 will produce a 3 cross 1 vector. I hope you all know that. So please imagine that X is a 3 cross 1 vector. The moment you say it's a 3 cross 1 vector, it means there are 3 unknowns, which is very, very important in deciding the nature of the solution. A 3 cross 1 unknown vector means it has got 3 unknown variables. According to the option A, so what option we are analyzing? We are analyzing option A. Mx equal to P has unique solution. This is what they are claiming, that Mx equal to Mx equal to P has unique solution. Okay. Now can you recollect, when does Mx equal to P have unique solution? This happens when rank of MP equal to rank of M equal to number of variables. It happens in the case of rank of MP equal to rank of M equal to number of variables. How many variables are involved? 3 variables are involved. And the same coefficient matrix M into X equal to Q should have infinite solutions. He is taking the same coefficient matrix, but he is changing the right side vector to Q, and he wants infinitely many solutions. Okay. So he wants Mx equal to Q to have what? Infinite solutions. So is this possible? Let's see. Now for infinitely many solutions, rank of M Q has to be equal to rank of M, and it should be less than number of variables. And how many variables are there? There are 3 variables. So the rank of M has to be less than 3. Alright, what is this? Here you want rank to be less than 3, and here you are saying the rank of M must be 3. How can the same matrix M simultaneously have rank equal to 3 and rank less than 3? That means such M, such P, such Q are not possible in option A. You cannot have Mx equal to P to have a unique solution, and Mx equal to Q to have infinitely many solutions. This is contradictory. So option A is false. So this is like equivalent to 4 questions actually. So what did I say? Option A is false. I hope you're all following this. If you have any doubts, you can post it in the live comment box. I'll try to reply. So as of now, A is false. Let us analyze option B. So what are they saying in option B? So once again, fadafat you write what is M. So this is option B. M is a 3 cross 3 matrix, P is a 3 cross 1 vector, Q is a 3 cross 1 vector, and X is also a 3 cross 1 vector. According to them, Mx equal to P has no solution. Okay, Mx equal to P, no solution. So when is this? So when do you have no solution? I have an idea. When rank of MP not equal to rank of M. So this is when you will have no solution. Rank of MP not equal to rank of M, that's when you will have no solution. Now what shall I do? Let me just see what will be the order of MP. Basically M is a 3 cross 3 matrix. It will have 3 rows and 3 columns, and when you look at the augmented matrix, you will add one more column. So this is basically a 3 cross 4 matrix. So for a 3 cross 4 matrix, the maximum rank possible is 3. So what I'll do is I will set rank of MP to be 3, which is possible. Yes, you can create such matrix. And if you look at M, which is a 3 cross 3 matrix, it can have rank 2. So here MP is a different matrix, it's an augmented matrix. Augmented matrix can have rank 3, and M is different, it is not augmented matrix, it is just M, it can have rank 2. So in that case it leads to no solution. So the problem is not yet completed. The first part I tried to analyze. So what next? So the first part, no solution. Yes, this can be a situation where you can have no solution, and he wants Mx equal to Q to have infinitely many solutions. Okay, Mx equal to Q, infinite solutions. Infinite solutions. How is this possible? So when rank of MQ equal to rank of M less than number of variables. Is it possible? Yes, it is possible. I'll tell you. We can have rank of MQ to be 2 and rank of M also to be 2. So here rank of M is 2, here also rank of M is 2, such M can be created. So there is, like the previous case, there is no mismatch. Here I can still have rank of M. This is basically a 3 cross 3 matrix, it can have rank 2. It's a 3 cross 4 matrix whose rank can be 2, no problem. So this is true, there is nothing wrong in this. Such M, such P, such Q matrices or such matrix M, P and Q vectors can be created. So there is nothing wrong in this. So option B is true. Likewise, we have to examine C and D. Options C and D are even more interesting. So what is option C? In option C, M is a 2 cross 3 matrix, P is a 2 cross 1 vector, Q is also a 2 cross 1 vector, such that Mx equal to P has unique solution and Mx equal to Q has infinitely many solutions. Now students, M x equal to p. I want to know what is order of x. This is very simple. A 2 cross 3 matrix when multiplied with 3 cross 1, see here I am writing it. A 2 cross 3 matrix when multiplied with 3 cross 1 will give us a 2 cross 1 vector called P. So meaning by what should be x? X is a 3 cross 1 vector. It will have 3 unknowns. It will have 3 unknowns. So what's the first thing? He wants mx equal to p to have unique solution. So he wants unique solution. Okay. He wants a unique solution. So for unique solution, we have rank of MP equal to rank of M, and it has to equal to number of variables, which is 3. Yes or no? Rank of MP equal to rank of M, it should be equal to number of variables. Here the number of variables are 3. But rank of M can never be 3. Rank of M, what is M? It's a 2 cross 3 matrix. The rank of M can never be 3. Why? Because rank of a 2 cross 3 matrix is always less than or equal to 2. So this is also ruled out. This is a false statement. This is clearly a false statement. So option C is gone. Option C is false. Now we are left with one more option, that is D. So let's analyze D. So you should write it quickly. What is M? It's a 3 cross 2 matrix. What is P? It's a 3 cross 1 vector. Q is a 3 cross 1 vector. If you look at mx equal to P, it's like you take a 3 cross 2 vector, multiply with 2 cross 1, which leads to 3 cross 1. So meaning by what should be x, x should be a 2 cross 1 vector. What is x, students? X should be a 2 cross 1 vector. If you say 2 cross 1 vector, that means there are 2 variables, only 2 variables. And I want mx equal to p to have unique solution. Okay. So first of all, what is order of M? It's a 3 cross 2. When it is augmented with P, P is 3 cross 1. I want to know what is order of this matrix. Already this 3 cross 2 has 3 rows and 2 columns, and then it has 3 rows and only 1 column. So when you club this, the augmented matrix order would be 3. And what you want a unique solution. Okay. So mx equal to p, unique solution if you want. Then we need this rank of MP equal to rank of M equal to number of variables, which is 2. Can a 3 cross 3 matrix have rank 2? Possible. What is M? 3 cross 2. See here, this is 3 cross 3. Can a 3 cross 3 matrix can have rank 2? Yes, possible. What is M? It's a 3 cross 2. Can a 3 cross 2 matrix have rank 2? Yes, possible. So unique solution is possible. So for that, rank of MP and rank of M has to be 2. At the same time, mx equal to q has no solution. So this is the final point. Mx equal to q, no solution we want. Is this really possible? Let's see. Now rank of mq. So first of all, mq is augmented matrix whose order is 3 cross 3. Just like order of mp is 3 cross 3, the order of mq is 3 cross 3. For a 3 cross 3, the rank can be 3. And then when you look at rank of M, so what was the earlier rank of M? 2. So if I set rank of M as 2 and the rank of MQ as 3, no solution is the answer. So such M, such P, such Q can be created here, or such M, P, Q can exist in option D. So option D is true. There are 2 correct answers. One is B and other is D. So what are the right answers for this question? B and D. I hope you have understood this problem. Fantastic question. It takes a lot of time for you to understand. So please let me know whether you have understood this or not. So looks very lengthy actually. It is equivalent to 4 questions actually. 4 lengthy questions. So students, can I know whether are you following or not? Okay, so there are no comments so far. Hope you are going through the problem. So if you prepare these kind of questions, you get new ideas, you know how to handle them in the exam. So once again, we have come with MSQs and NATs, which are very important for your exam point of view. So can we proceed? So this is another fantastic problem. They are all very good problems, students, not that easy. It will test your patience. Once you prepare these kind of problems, then yes, there is a high chance that you will also crack the 2026 questions. Let f be a function from R to R, be twice differentiable function, and suppose its second derivative satisfies f double dash of x greater than 0 for all x belonging to R. Which one of the following statements is or always correct? F has a local minima. There does not exist x and y where x is not equal to y such that f dash of x equal to f dash of y equal to 0. F has at most one global minimum. F has at most one local minimum. These are the various options. I'll give you a minute time just to read and understand the question. So now what I suggest is the students who know about convex function, basics about convex function, for them this is very simple. So what information they gave? That f of x is twice differentiable and its second derivative is always greater than 0 for all real numbers. So please students, the moment a function satisfies this f double dash of x greater than 0 for x belonging to real numbers, clearly f of x is a convex function because this is the mathematical definition of a convex function. So what is f of x? F of x is a convex function. So the more properties you learn about convex function, handling this would be very easy. Now let me handle option A. In option A, it says f of x has a local minima. Let me take a counter example where f of x is e power x. If you look at f dash, it is e power x. If you look at f double dash, it is also e power x. Clearly, e power x is always greater than 0. For all real numbers, e power x is something which is greater than 0. Yes or no? So that means this is like a best fit in the discussion. Do you know how to draw the graph of e power x? When you look at the graph of e power x, it is like this. This is the graph of e power x. Do you feel this function has a local minima? Students, come on. Do you feel that this function has a local minima? Can anyone help me in this? Does this function have a local minima? The way I have drawn this, e power x, the way I have drawn, does not have any local minima. E power x does not have local minima. But they are saying The moment it satisfies f double dash of x greater than 0, it has a local minima. This need not be true always. So this is not true always, hence this is a false statement, and here we have a counter example for that. Next, I'll try to explain BCD. If you properly analyze B, you will also get C and D. So for that you have to learn about convex function. More properties you learn, answering them would be easy. Especially for data science students, you should know what is a convex function, what is a concave function. Other branch they need not learn in this depth, but for data science students, since the weightage is nearly 40 marks, you have to cover a lot of basics. So let's proceed. So look at this. If f dash of x is greater than 0, if f dash of x is greater than 0, then I can say f of x is increasing. It's an increasing function. Yes or no? Like we say, if the slope is positive, the function increases. Right? If f dash of x is greater than 0, then f of x is an increasing function. Now, what can I say? Can I also add a point like this? If f double dash of x is greater than 0, then its first derivative, that is f dash of x, is an increasing function. The logic is clear, huh? And if f dash, if the derivative is greater than 0, then the function is increasing function. If the second derivative is greater than 0, then the first derivative is an increasing function. In the present question, he gave f double dash of x to be greater than 0. That means f dash of x should be an increasing function. This will almost give us the answer. I'm trying to look at how does f dash of x look like. So it should be like an increasing function. I'm just roughly showing you how does an increasing function look like. Maybe something like this. Your f dash of x should be like this, or it can be like this also. It can be like this as well. I just need it to be a increasing function. It can be like this also. So sir, why are you trying to draw f dash of x, sir? Now when it is increasing function, f dash of x can intersect x-axis at most one point. F dash of x will intersect the x-axis at most one point. If f double dash of x is greater than 0, then f dash of x is an increasing function. It will intersect at most at one point. See here, it is intersecting at this point, and here there is no intersection at all. Sir, why are you worried about f dash of x intersecting with x-axis? Because wherever f dash of x intersects the x-axis, that is the corresponding x point is the stationary point. So now what I want to say is, so look at this. When f double dash of x is greater than 0, then f of x has at most, what do you mean by at most? It can have one stationary point or no stationary point. Then f of x has at most one stationary point. So what can we say is, we can say that it has at most one stationary point. So at most one stationary point means exactly one stationary point or no stationary points. Now you try to read option B. There does not exist x and y. There does not exist two points, different points, such that f dash of x equal to f dash of y equal to 0. So he's saying, array, multiple stationary points do not exist, it seems. I also said the same thing, na? Right? At most one stationary point can exist, I said. He is also saying that. So I have to agree with that. It's true. Now, when you say it has at most one stationary point, then there will be at most one local minima. Because suppose if it has let's say it has one stationary point. At that stationary point, the second derivative is anyway greater than 0, so definitely it's a local minima. So if you say if it has at most one stationary point, then it will have at most one local minima. So where is that? F has at most one local minima. This is true. Sir, how do you know that it will be at most one local minima? First of all, I have confirmed that there is at most one stationary point. In the case of one stationary point, the second derivative is positive, hence it's definitely a local minima. So second derivative positive means it's a local minima only, na? So at most one stationary point means it leads to at most one local minima. Now, the next fantastic thing. For a convex function, whatever, suppose if there is a local minima, definitely that will be a global minima. So if f has at most one local minima, the moment a convex function is having a local minima, that local minima will be a global minima. That means this is also true. So this is the property of a convex function. Imagine a convex function which has one local minimum. So definitely that local minimum is also a global minimum. So this is the interesting property of convex function. So what are the right answers? The right answers are B, C, D. What are the answers? B, C, D. So I'll give you a minute to review this question. Till then I'll be reading your comments. Please let me know whether you are following this. This is very interesting problem, student. You can see the way this is solved. I hope you people have understood it. I'm trying to read your comments. I don't see any comments so far. So take a minute, try to review this question. So usually MSQ questions are little lengthy actually. So you have to solve them quickly. Time management is really important. So please let me know in the chat. I'll be very happy if you have got this idea. So everyone is silent in the chat section. I hope you are following. Can someone reply me in the chat? Yeah, Ankit Singh says yes, clear. Thanks, Ankit. So then let me continue. So this is another question which is NAT question, numerical answer type. The unit interval 0 to 1 is divided at a point chosen uniformly distributed over 0 to 1 in R into two disjoint subintervals. The expected length of the subinterval that contains 0.4 is. So they have a unit interval, it seems. Okay. Let's mark this value as 0. Let's mark this value as 1. Is divided at a point which is uniformly chosen again over 0 to 1. So randomly they are picking one value between 0 to 1 and then they are breaking this interval into two disjoint intervals. The expected length of the subinterval that contains 0.4 is. Okay, so this looks little complicated. So what I'll do is I'll write some description. Let x be a value or let x be a point which is uniformly chosen from the interval 0 to 1. Uniformly chosen from the interval 0 to 1. For example, if I select x value as 0.2, let's see what happens. I'm just randomly selecting. You can also randomly select any value between 0 and 1. I have chosen 0.2. Then I have to break this interval at a point called 0.2, and then it gives me two disjoint intervals. What are those disjoint intervals? So one is from 0 to 0.2, one is from 0 to 0.2, and what is the other one? The other one is from 0.2 to 1. Yes. Now, which subinterval I am interested in? Are you interested in the interval 0 to 0.2 or in the interval 0.2 to 1? Actually, I am interested in the interval 0.2 to 1 because this is the subinterval which is containing the value 0.4. So this is where you have 0.4. Now the question is, look at its length. This length you try to see. Okay, so here right now the length is 0.8. Because this is 0.2 and this is 1, this length is 0.8. I'll write one more description here. Let capital Y be the length of the subinterval. I'm writing in short. Let capital Y be the length of the subinterval that contains 0.4. That contains 0.4. So right now at this point, what is Y if you ask? Y is 0.8. Can I also write like this? Y is nothing but is it 1 minus x? Because x value is 0.2. You try to substitute 1 minus 0.2 is 0.8. So right now I have this relation. Maybe I'll go for a few more x values. So let me take 0.3. Then where will you break the interval? I have to break at 0.3. So the value would be 0 to 0.3. One interval would be 0 to 0.3 and the other interval would be 0.3 to 1. Which interval you will be interested again is this interval, because this is the one which contains the value 0.4. Now again I am interested in knowing what is length of this interval. What is length of this interval? The moment you change x value, the length of the subinterval which contains 0.4 also changes. That means basically y is also a random variable. So how much is this length right now? It is 0.7. Can I say that y follows a relation like it is 1 minus x? Because when you put 0.3 here, 1 minus 0.3 is 0.7. So far I have taken 0.2, 0.3. Let me proceed. Let me take x value as 0.6. Some value which is greater than 0.4 I have taken. Then where will you break? When you break, you get two subintervals. The two subintervals are 0 to 0.6 and then another subinterval from 0.6 to 1. Which subinterval are you interested? I am interested in this subinterval because this is the subinterval which contains the value 0.4. So do you know what is y here? Y doesn't follow the relation like 1 minus x. Here, for example, here the length of the subinterval is 0.6, which is directly x. So this is 0.6. I can see that for this choice of x, y is directly x. Let me take one more value just for our understanding purpose. Let me take x to be 0.8. So you have to break it. So one interval would be 0 to 0.8 and the other subinterval would be 0.8 to 1. Again, I'm not interested in this. I'll be interested in this because that is the one which is containing the value 0.4. So what is length of the subinterval? It is 0.8. Can I say that y is again x here? So sometimes y is equal to x and sometimes y equal to 1 minus x. Basically y is a function of x. What is y? It's a function of x. So now I have understood one logic here. If x is something which is less than 0.4, then do you know what is y? Go through the cases. 0.2, 0.3, what was y? It was 1 minus x. So what is y? 1 minus x. If x is something which is greater than 0.4, then do you know what is x? Sorry, do you know what is y? Y is directly x. So now I found that the length of the subinterval which contains 0.4 is a function of x. Try to recall what is expected value of g of x. Expected value of g of x is integration x from minus infinity to infinity. It is g of x into the probability density function of x. So what is the probability density function of x? Here x is a uniform random variable in the interval 0 to 1. Its density function is 1 by 1 minus 0, which is nothing but 1 in the interval 0 less than or equal to x less than or equal to 1, and it is 0 elsewhere. Everything is now ready. We know the density function. We know that y is a function of x, so something like expectation of y here. So now let's write the expected value of y, the last step. The expected value of y or expected value of g of x. So what I want to do is, it will be like this now. X from 0 to 1, it is y into f of x dx. Sir, how did you know? Why are you writing y, sir? Basically, what is y? It's a function of x. So see, how did you write here? Integral g of x into f of x dx you wrote. And why the integration limits are from 0 to 1? Because x is uniformly distributed in the interval 0 to 1. I want to separate this integral, or I want to write like this: 0 to 0.4. Where x is from 0 to 0.4, the value of y is 1 minus x. So this is 1 minus x into f of x value is 1 dx plus integral 0.4 to 1. When x is from 0.4 to 1, that is this case, the value of y is x. So this is now x into 1 into dx. Simplify this, you'll get a decimal value. That will be your answer. Can I expect some answers here? So I'll do some calculation. So here it is x minus x square by 2, and the limits are 0 to 0.4. And here it is x square by 2, the limits are 0.4 to 1. Can you use the virtual calculator? Can you simplify, get me a decimal value for this? I'm waiting for your replies. So can you please solve this and let me know the decimal value? So let me check it. So when I substitute this, this will be 0.4 minus 0.4 whole square by 2. Then it is 1 by 2. And then when I substitute this, this is minus 0.4 whole square by 2. Is everything okay? Yeah, everything looks correct. This lower limit is anyway gone. This is 1 by 2, 0.5, that is 0.4. So this is 0.9. And when you combine this, it will be minus 0.4 whole square. 0.9 minus 0.16. How much is this? I don't need a virtual calculator actually here. I'm getting the answer as 0.74. Can you people confirm it? Students who are watching live, can you confirm this answer? Okay. So that's it for today's live. I have few more details to discuss with you. Like, I wanted to share few things with you. Let me just share those details. So we are actually launching GATE 2026 revision series, which starts from 10th January. So these are the various branches for which we are offering this revision series. Yesterday I have taken the live. One of the student was asking, like, will you cover the entire syllabus? Will you give us a quick recap of the entire syllabus? Yes, we will definitely cover. It's like a revision session. First of all, please understand, it's a revision session. We try to recap you all the concepts that are given the GATE syllabus, and we also try to focus on the most important concepts. And if needed, we will also solve. In our previous revision sessions last year, I think we have solved few GATE questions also, or the expected questions. So this is definitely a useful thing for you. And then, to register for this, the present A students, they need not register. This is like, they get this revision series, they get the schedule in their app, so you need not separately register. This is for the students who are uh, joining us for the first time. So they have to scan this QR code, complete the registration process, and if you use this coupon code, that is gate26, you'll get the 30% discount. So this is one announcement. And the other announcement is, so every day we are having the YouTube live. So after the class, we will try to upload the PDF. If you can scan this QR code, you will get the PDF. Like yesterday's live session PDF is already uploaded. Just you have to scan this, you will get the PDF, you can download it. So once again, I want to share this GATE revision uh, series information, which starts at 10th January. We will complete all the subjects. Like, we will give you a quick recap of all the subjects which are in your uh, branch. So these are the branches that we offer. Any other doubts? I'm here to answer for a couple of minutes. I hope you people have got a good idea like how to deal with NAT and MSQ questions, and I'm happy with the way you are replying. So I hope these sessions are very useful for you in the coming days. Thank you. So that's it for now.